Good morning. Welcome to Meritor's monthly IDT seminar. We're going to be discussing hydraulic brakes, specifically the Quadraulic disc. Again, my name is Eric Hyatt, and I'm a technical product specialist with Meritor. So let's talk about the Quadraulic fixed caliper disc brake. It is fixed and not floating and is attached by 4 or 6 bolts from the caliper to the anchor plate. There are 4 opposing pistons in the design, 70 millimeter design or 64 millimeter design. It attaches with either a 19.5 inch wheel with 8 holes or a 22.5 inch wheel with 10 holes, and that could be a hub pilot or a stub pilot system. In its application, it's rated between 18,000 and 33,000 GVW. So in the designs, there is an HD design, heavy duty, 64 and 70 millimeter with a 2 and 4 bolt mount. 4 and 6 bolt mounts. If you look at the color of the boot, that will help you determine what size the piston is. A red boot is a 64, and a black boot is a 70 millimeter. Also, you can use references to the bolt size of a 20 millimeter and a 14 millimeter. There's also an additional version of the 64 millimeter called the Lite. It still has the same red boot for the 64 millimeter design, but it only has 6 bolts, and those bolt sizes are 16 millimeter compared to the 14 millimeter on the previous page. So when torquing the plate to the spindle, you must refer to the manufacturer specifications for that torque spec, because there are different types of fasteners and thread count that drive those torque specs. When you're attaching the caliper to the anchor plate on the 14 millimeter size bolts, you have to refer to the manufacturer's spec. Otherwise, on a 20 millimeter bolt, the spec is from 320 to 360 foot-pounds. And on a 64 Lite caliper with a 16 millimeter bolt, it's 199 foot-pounds to 258. The Quadraulic 4-piston caliper comes handed. So in the view, you have shown, which is a left view, and opposite, which is the right view, and that is the same way it will appear in the catalog. Distinct designation of the left and right is where the cross tube is located. So keep that in mind. In the catalog, you will see that the Quadraulic brake is broken down into a millimeter size as well as bolt size. So the best way to determine the caliper without having a part number is to determine first piston size, second, determine the number of anchor bolts, then third, determine the size of the anchor bolt, since there are 2 different 64 millimeters with a 14 and a 16 millimeter size bolt. Also, there will be references to a casting number on the outside of the castings that you can also use as a reference tool to find the right caliper. So in the diagnostics of the Quadraulic brake, we find that we have some accelerated inner pad wear or inner or outer pad wear. Environmental conditions really dictate a lot of that pad wear, because the lining itself has to retract, and if there's any debris that gets into the piston or piston seals that do not allow that to retract properly because of buildup, you're going to have additional pad wear. Dust shields are recommended in those applications where dust is a problem. Next is the chronic long pedal. As we do multiple brake applications, we heat up the brake fluid, and as temperatures rise, you can get to the point you vaporize the fluid. That vaporization is above 400 degrees, and now you have gas along with the fluid from the backside of the piston. which gas is compressible, so you end up having a longer pedal stroke in order to apply the pressure. Additionally, wheel bearing settings can accelerate pad wear. We'll talk a little more about that later. Rebuild recommendations. 1, steel pistons are no longer available from us for production and service. So we only want the phenolic type pistons being replaced in the caliper. And note that that piston and boot and seal is different, so it does not interchange with the steel piston. You must replace all 3 components. Wheel bearing adjustment. If you see tapered evidence in the pad to rotor wear, top to bottom, this is an evidence that the wheel bearings may not be set properly. So what you should do is grab a hold of the hub, pull in and out. If you can feel the movement, it is most likely too much. It is hard to feel the 5,000ths max that is part of the bearing wheel bearing spec. And if you have preset hubs, there's a 0 movement. So please adjust the wheel bearings upon reassembly so that we don't have this tapered pad wear. Rotor failures. So one of the things you're going to look for is the runout. So you got lateral runout, which can't be more than 15 thousandths, and you have radial runout that can't be more than 35 thousandths. Now, from a parallelism, that is the tightest of the spec, and it's only 1.2 thousandths variation in the rotor surface. Surface grooves, we can have up to 20 thousandths width and up to 40 thousandths in depth before we have to replace the caliper. Cracks through the edge of the caliper are not permissible by DFU laws, and therefore it must be replaced. If you look at a heated rotor, the heat into a rotor usually leaves a sign of bluing to the rotor. At that point in time, a blue rotor is actually harder, and it doesn't grab the pad as well. So we recommend you always replace any rotor that has been heated up. Reading the wear patterns. So uneven wear, inner versus outer, usually means there's something going on with the caliper pistons on the application side and or the retraction side. It can be due to leakage of fluid. It can be due to air in the system. It can be due to heat that's driven the fluids to vaporize and cause a residual gas pressure. So residual hydraulic pressure can happen either in a corner of the vehicle due to a bent hose or something, or across the entire vehicle because the master cylinder maybe isn't releasing all of the pressure. The spec is 1 psi. So we must figure out why we have residual pressure to allow the pads not to be dragging in contact with the rotor. As the friction material failure, when friction completely delaminates from the backing plate, that is an adhesion problem to the backing plate itself. And we've done some things to correct or help that problem from ever happening in the future with our newest designs. And we'll talk about that in a second. What we want to do is we always want to get the operator's input from the complaint. So is there noticeable vibrations, noise, grabbing brakes upon application or release? And write that information down to help us for our diagnostic. Quadraulic caliper tolerances on the pad and rotor. The pad thickness new is 0.730. So we want to discard and or replace it when it gets to the 0.125, which is 1/8 of an inch. The rotor thickness, it's 1.530 thousandths, and we disregard, and that's at new, and we will discard it at 1.410. Again, the quality of the brake stopping power really depends on the couple between the pad and the rotor. So replacing both surfaces, both always gives you the best braking application. Friction material and noise. If you really look at noise can be produced from the friction pad if it is glazed. So what is glazing? Glazing is where we heat up the pad, we bring some of the resins to the surface. And if we're too light on the applications, we don't burn them off. If we're too heavy and get the brake pads too hot, we bring too much of the resin to the surface. Either case, we can get a glazing to the pad. The glazing is the darkened black area that looks very shiny. That will cause noise in the brake pad. So we'll talk about how to prevent that here a little later in the conversation. Worn lining. So wearing from left to right evenly or from top to bottom evenly. We need to inspect for that and then take into consideration what the additional repair is going to be required other than just putting the pads back in. Contamination from even materials that we use for cleaning the rotor surfaces or on our hands can cause additional problems with noise. So we burn that material off, it will cause and can cause noise problems. So the pads come in two brands. They come in a Euclid brand or a Meritor brand today. They're semi-metallic with air met fibers. They have chamfered edges on each end to reduce noise. They have a mechanical retention process to bond the friction material right to the pad itself. We also put in wear indicators so that you know when you're out of compliance with that pad. So coming soon, we will actually have an additional brand called the Mod brand. Again, all of our brands go through the same testing process and approvals that are in accordance with 121 law. That mechanical retention process is in the picture below. You can see it's a robust hooking process. So we mold the friction right into those hooks so it cannot detach from the backing plate. And the benefit you get from this is additional protection against rust jacking, where rust gets up underneath the pad and it will actually push the pad up and will most likely cause cracks in the lining itself. So let's talk about brake burnishing. Why should we brake burnish? Well, there's a factor, a thing called green fade. So we need to control that. And it's in all new brake lining materials because as we initially put them into the vehicle and start our braking applications, we give off a gas. That gas can cause, it's from the resins, it can cause a hydroplaning between basically the pad and the rotor surface until we can burn that gas off. Additionally, when you go through burnishing, as we're burning that gas off, we are thermal setting the resin in the pad itself. It takes several heat cycles to do that, but now we stabilize that material. So finally, you'll see that we also, as we go through that process, we transfer some of that, a layer of film between the pad, from the pad to the rotor, so that when those two contact, they have a more effective friction coupling. So when you do these type of performance braking in on the pad, you're going to get a better performing brake and you're going to get a noise-free brake job. So here is the specific burnishing procedure. Drive the vehicle from 20 to 25 miles per hour. Apply light service brake and apply a light engine throttle to maintain that speed for 15 to 20 second duration. Then release the brakes for 15 to 20 seconds. Take a handgun or a temperature gun with you so you can check the rotors periodically. As you're building temperature, keep repeating that process until you reach 450 degrees on the coolest end of any one of the wheel ends, but not to exceed 550 degrees, which too many of the resins are starting to come to the surface at that time. Okay? At that point in time, the rotor temperature difference from one side of the vehicle to the other side of the vehicle across an axle should not be more than 50 degrees Fahrenheit difference. If there is a condition where that is higher, there is an imbalance in the system that you must correct before you can go forward and put this vehicle into service. Once you've achieved that, everything's balanced, bring it back to the service facility, let it sit and cool for a minimum of 30 minutes until the brakes achieve ambient temperature. Then look underneath the vehicle to see if there are any additional fluid leaks from line and or the caliper. Caliper-related issues. What are some of the causes for caliper pistons not returning to rest? Well, we talked about earlier residual pressure. So as we build temperature, we can build gas. And if we build gas, now we have an extra pressure that has to get relieved from the system, and it's going to have to permeate back to the fluid up to the master cylinder to get out. So that's where we get some residual pressure. Controlling temperature is probably the only way to eliminate that specific problem. But we want to make sure that we don't have other problems where we have a kink line, pinch line that's holding pressure, could be on the wheel end, and or a master cylinder that's not allowing the fluid pressure to release. Additionally, when you're looking at this, you want to make sure you look at the lining spacers. So those are at the end of the pads, and they help allow the pad to easily move in and out upon brake application or release. You got to make sure they're not corroded and or bent. If you look at the last thing, pistons that are starting to seize are binding in the bore. If they can't apply out properly, and you can visually see that by the wear on a pad, you need to start looking internal. So rust and corrosion inside due to the fluid not being changed and or the seals degrading and allowing contamination in during the cooling process can drive to have a piston that's starting to seize. It should be evident in the color of the fluid in the master cylinder also. So let's talk about the metal piston. Why did we go away from it? The metal piston allowed to transfer more heat from the brake pad in through the metal piston that transferred heat into the fluid. And then we could, as we got the fluid hotter grades, it could cause rust back. You have rust in the bore or on the piston itself. So the phenolic pistons are a hard plastic type material that are extremely strong and a lot more heat resistant. We also put a heat shield on the end of that piston to reduce the heat transfer into the fluid. So that's the primary reason for us doing that. Also, the benefit you get from it, because it's a plastic, hard plastic type material, it's corrosive resistant, so it's less likely to help accelerate the corrosion in the system when fluid gets bad. They're also slightly lighter than the original steel pistons. So let's talk about the piston seals themselves. Water causes rust in the system. So water into the fluid can cause the rust to start growing throughout the system in the lines and in the actual piston cavities themselves. So those rust particles now become abrasive pieces, and they cause wear on the piston seals. Mixing of fluid can be another issue that can cause the seals to harden and deteriorate faster. So once the seals are hard, you can see under picture number 2 that the seal has to deform and during its application, but it must come back to its normal state upon release in number 3. So if that seal is hard, it will not reconform to the original fit and it will start to leak. So contaminations are the last thing to look for, the piston not retracting. You can see it, contamination builds up in the system, and it will be evident in the oil by color. You can see it in the rotor and or pad, as it does not allow the piston to fully retract. Therefore, you'll have a polished look on the rotor. It looks more like a mirror. And that is an evidence that the piston is not fully retracting potentially. Besides, when the piston doesn't fully retract, it creates a dragging, which causes heat. It's going to cause the friction material to wear faster, therefore shortening the brake life on the rotor as well as the pads. The root cause, though, in most cases, is contaminated fluid that destroys seals. So if you're replacing the pistons, you must retorque the bridge bolts properly. So we want you to install new bolts and use TP 10134 as your reference. This procedure is in that document, so it's a two-step torquing procedure. Tighten the bolts initially to 50 foot-pounds in the sequence outlined 1, 2, 3, 4 in the view. So it's a crisscrossing pattern. Then the next step is a second torque, which is torque plus angle. So the torque device you see below allows you to increment the head of the bolt another 70 degrees tighter. So I would always recommend mark it and or use this tool to know what that 70 degree movement is. That gives you the final torque. So there is no final foot-pound torque rating for that tightening process. Inspection of fluid. We got to look for contaminated fluid in the system. And you can see in the picture, you can see the dark color of the fluid. We should never see darkness in the fluid. The fluid is virtually clear. So as we build contamination, it is grit is one of the factors from the rusting and pitting in the cylinder or from some external dirt that might have in the system. But number two, wet fluid. Well, that's water that has been saturated into the fluid itself. Talk more specifically on that here shortly. So the recommendation is always to flush the system between 1 and 2 years. Refer to the manufacturer's recommendation if it's 1 or 2. When it comes to fluid types, never mix different hydraulic fluids together. We'll talk a little bit more about that here in a second. But never vary from the manufacturer's recommended rated fluid, because there's some other impacts in the system, including ABS systems retaining some of the old fluid in the modulator valves. So the biggest cause when an installer replaces brake pads is they do not completely flush the system, which basically becomes the next root cause of your fitting. So specifically, let's talk about the types of brake fluid. The hydraulic brake, Quadraulic brake, we only recommend DOT 3 or 4 glycol-based brake fluids. DOT 4 is compatible with DOT 3, but not the other way around. So for that purpose, Meritor does not recommend mixing different types of fluid together. And do not use DOT 5 because that is a silicone-based brake fluid and it will affect the seals. So check with your manufacturer for the correct fluid. If you look at the last step, regularly you should be checking the fluid for the proper boiling point of the fluid. You can see the chart below as it indicates what the boiling fluid is dry, and then if water gets into it, what is the boiling point wet. So brake fluid warnings. DOT 3 and 4 are both hygroscopic. That means they absorb moisture from the air. So humid areas of the country are in a bad situation because just opening a bottle or a container can draw moisture in. So let's look at DOT 3. For example, if you have 1% water, what does it do to the boiling point? It decreases it to 370 degrees. If you looked at the other page, it was 400 degrees dry. 2%, 320 degrees Fahrenheit. 3% water, 290 degrees Fahrenheit. You cannot see water in the fluid. It does not sit on top like it does on motor oil. So master cylinder reservoirs, brake fluid containers should always be kept tightly sealed and never left open for any length of time. minutes at max, in my opinion. So additionally, practice of handling material with mineral-based oils or cleaners that could contaminate through either your hands or through towels into the piston will cause the seals to swell. So how do I test the fluid? Well, there's two possible ways to check. The best is fluid sampling with a lab test. It's going to tell you how much moisture has been absorbed into the fluid, as well as what kind of contaminants are in the fluid and how abrasive they are. On a periodic basis, you should be testing through an electronic moisture testing device to see how much fluid has absorbed water over a period of time. Again, heating and cooling of a rotor and a caliper still draws some moisture in through the seals in that manner. Hopefully, you're not drawing it in through the master cylinder. You should be checking for that also. But on a periodic basis, whatever that is, if it's every PM that you bring it in, I would be checking for moisture content in the fluid. So brake fluid replacement. So we never want to push the fluid from the calipers back up to the master cylinder. Again, you're pushing all your contaminants up the system. Also, it could affect the master cylinder and the sealing in there. So unless otherwise recommended by a manufacturer, we never recommend it in Meritor. Open a bleeding screw, attach a hose to evacuate the fluid from a specific caliper as you're retracting the pistons. If the brake system uses accumulators similar to what Meritor Wapco has in their HPV system, that system has accumulated cylinders that have pressurized fluid that have to be bled down. And once that's bled down, they have to be built back up. You may have to do that a couple of times, as well as if they're integrated with ABS systems. ABS systems have modular valves. You must use a software to cycle those modular valves to pump that contaminated fluid and release it from the modular valves. So it is a little more complicated bleeding process when you do have HPVs and or ABS systems in conjunction with the system. So when you look at the caliper itself, so where do I start? We have two bleeder screws on the caliper. So first, we're going to make sure the reservoir is topped off at dot 3 or dot 4. Attach your clear line tube and put it into a container and put a little bit of fluid in the container. Pressurize the system is probably the best way through an external pressurizer and or hold the brakes as you break open the bleeder valve. Okay, so where do I start? So when you're starting with a caliper, you always start with the inside or inboard bleeder screw, then go to the outboard bleeder screw, then repeat going back to the inboard, just in case there was a little bit of a pocket there. So what wheel end do I start with? We always start with the ones that are farthest or longest line. So we start with the right rear, then right front, left front. When you're completed, tighten the screws, test the brakes. If there's any sponginess whatsoever, you cannot just bleed one of the wheel ends. You must go through the entire process again. Refer to TP 09123 or Maintenance Manual 2075 for additional information on bleeding the brakes. So, in conclusion, what is a complete brake job? So replacing the friction with the appropriate friction that was originally designed for the vehicle is probably the most important thing. We don't want to sacrifice friction material based upon price because we won't get the same benefits and it will drive probably additional heat into the system because it takes longer to stop the vehicle. When we're looking at the hardwares, always replace the hardwares in the lining spacers because that's a wearing point in the system and those help hold the pads in place and allow them to move in and out. When you're looking at rotors, we gave you the specs earlier as to what to do in terms of inspecting a rotor. You can reuse more within those specs, but remember, when you wear a rotor, you're losing cast iron material, and it does not absorb heat as easily as it does when it's brand new. So new rotors are always the right answer. From a lubrication standpoint, when you're putting the pistons, if you rebuilt the calipers yourself, if you're putting the pistons back in, use the same dot fluid for the system as your lubrication, and you can use a little bit of silicone grease on the seals, lip seals of the seals. The calipers themselves, we recommend you always replace the calipers and sets left and right side of the vehicle so we don't have any issues from a pole perspective, and making sure that you put the right caliper back on. When flushing the system, you must flush it completely, and we talked pretty extensively in the previous slide to make sure that that system is flushed completely. That will be your biggest culprit to having a repeat failure in a short period of time. The last piece I want to talk about is driver education. It is important that you feed back to the driver if it involves heat as part of the related failure. So heat in the rotors or heat or where you see the fluid has been boiled means the driver may be overtaxing a brake. So some applications are very frequent brake stops, and we have to figure out how to maybe do them at a little slower speed so we don't build as much heat. And number two, we don't want to be overloading the vehicle above its GVW rating, because the brake system was not designed for that extra weight. It's going to work harder, therefore cause problems that way. So using the correct tools, the appropriate techniques will prevent comebacks and dissatisfied customers. It's simple as that. So again, refer to Maintenance Manual 2075 or TP 09123 for fluid-related issues, and TP 10134 when you're rebuilding the caliper and the score grades. Thanks for joining us for this month's seminar. Next month's seminar will cover air dryers. Again, thank you. This is Eric Ian, Product Technical Specialist in Meritor. I appreciate your time, and I hope this is beneficial to you.